Assalamualaikum warahmatullahi wabarakatuh. My name is Zulfikar Faisal Haq. I will explain about the Scada system with the title of my percentage is Instrumentation for Scada system from power generator to grid network. First, I will show you the diagram power grid system. This is diagram power grid system, where there is a power generator unit that transmits electrical energy with a high voltage line 180 kV to a high voltage substation. Then it is branched and distributed to distribution substation through medium voltage 20 kV channel. Low voltage 220 volt. The distributed voltage depends on the type of customer, which is divided into several groups, from small industry, light industry, office to hosting. From the explanation of the flow diagram of the power grid system, there is a control center for control of the electric network from the source to the load. The control center usually uses the Scada system. Next, the system is a collection of several tools or components that form a unity and work together, while Scada stands for supervisory control and data acquisition. Scada system is a unit of several equipment that communicated with each other to carry out the function of monitoring, controlling, and collecting data from a process. There are two basic principles of the Scada system, namely 1. Monitoring and control all equipment contained in a system remotely. 2. Scada work to collect information, then transfer it to a central carry data and control signal, which are then displayed on the number of operator screen. Next, Scada is a system for remote control and monitoring. In the Scada power system aims to help get the optimum operation system. In general, the control process in the remote electric power system consists of four kinds, namely: first, control of opening, closing of the power breaker, separator, and start-stop of the generator. 2. Control of regulator, device such as setting the set point or raising and lowering the position of the tap changer. 3. Third, load monitoring and regulation. 4. Automated control for uniformity and command control sequentially, for example, changing the network configuration. With Scada supporting facilities, the load control center can get the following benefit: speed and ease of obtaining the required information. The quality of the displayed data can be monitored in real time or need data. Ways of presenting data and informating for perfect system administrator. And last, the load control center operator can easily set up the system. Next, dispatcher or system operation personnel, who are the main user of Scada, who have the task of monitoring all electrical and network parameters without the need to look into the field. Information on measurement and status indication of the electric power system is collected using equipment located at the substation and the power plant. Next, control center. The control center of the global automation system, namely the control of several substations covered in the territory. Control center is located outside the substation or somewhere. And next, remote terminal unit or RTU. RTU is one component of an electric power control system which is an electronic device that can be classified as a smart device. Example RTU with control cable or radio communication media, RTU with fiber optic communication media, and power line carrier or PLC. In principle, the RTU has the following main function. First, detect switch position change, open or close or invalid. Knowing the amount of voltage, current, and frequency at the substation. Receive remote control commands from control center to open or close. And last, sending data and information to control center. In order to be able to perform data acquisition and control a substation, a terminal that can meet the requirement is needed, namely a remote terminal unit or RTU. The RTU must be equipped with panel, transducer, and wiring. The master station sequentially scans the RTUs by sending a short message to each RTU to see if the RTU has information that needs to be reported. If the RTU has something to report, the RTU will send a message back to master station, and the data will be received and entered into the computer memory. If needed, the message will be printed on the printer machine in the master station and displayed on the monitor screen. In addition to the scanning system, data exchange can also occur incidentally. For example, when the circuit breaker switch is closed by the substation operator, the RTU will automatically immediately send the CP status at the substation to the master station. The dispatcher will immediately notice that the CP has been closed. In the event of fault with the RTU, a message will be sent from the fault RTU to the master station, and a normal scan will experience a considerable delay because the master station precedes the fault message and set off an alarm so that the operation can take the necessary action as soon as possible. At the other times, in most cases, the status of all equipment on the RTU can be monitored every 2 seconds, providing information on the current state of the system to the operator in the control center. Next, communication media. Communication media is one of the most important parts that control is separated from an electric power control system, namely a subsystem, which is a telecommunication facility used to connect the control system device, especially between the master station and remote terminal unit device. Next, sensor. Sensor and control relay are directly connected to the various actuators in the system being controlled. And next, PLC. PLC or Programmable Logic Controller is a logic controller that can be programmed according to our need. PLC in Scada system are usually placed on the RTU. So PLC is subsystem of the RTU. This PLC is in charge of processing or retrieving data from the transducer or sensor transmitter, which also make it possible to control the system at the RTU. For example, it is used for valve opening setting. Next, master station. This is a master station. Server, workstation, historical data, project mimic used to still use the mimic board, working peripheral such as printer and logger, recorder, global position system for time reference, dispatcher training simulator, Scada application and energy management system, uninterruptible power supply or UPS to maintain the availability the electrical power. And the last, automatic transfer switch or ATS and static transfer switch or STS to control the flow of the electric power to the master station. At display level, it is used to control equipment in the field to be able to communicate with central control in terms of sending or receiving control command, as well as sending or reading data given by the control center operation and confirmed through status message sent back from field condition to the control station. Through RTU, it can be easily controlled and monitored by the operator through and the control center, where the bay level requires a device for component communication in the field that is converted in the form of data that has been processed on a controller. Later, the data received by the sensor in the field will be translated or converted by the controller before being sent through the RTU. Next, device at bay control level. For example, equipment that is at the bay level before data is sent to the station level and data from the control station is forwarded to field equipment. Data input or telesignaling or TS is equipment that function that to take education from electrical power equipment at the substation, which will be delivered to the master station at the regulator center. Digital output or telecontrol digital or TDC is equipment that function to carry out control or command from the central control to the equipment at the substation to change the status of electric power equipment, such as PMT and PMS. Next, analog input or telemetering or TM is an equipment that functions to take electrical quantities in the form of voltage, current, frequency, active power, and reactive power, which is acquired by the analog input RTU module. Analog output or telecontrol analog or TCA equipment that function to produce analog signal output such as voltage level. Next, transducer. Transducer is device that convert high voltage or high current power from the GT or VT secondary to low voltage or low current output, so that it can be utilized by the analog input circuit on the RT. Modem. Modem is an interface communication device between the RTU and the master station through data communication media such as PLC, fiber optic, pilot cable, and other. Modulator. The modulator functions to convert digital signal into analog signal. And demodulator. The demodulator functions to convert the modulate sinusoidal signal into the digital signal. And last, communication protocol. The communication protocol is the language used in the Scada system between the RTU and the master station, which is based on the data communication media. Yeah, that is all from me. Thanks for watching. Wassalamualaikum warahmatullahi wabarakatuh.